Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem: n meetings in one room. So what the problem is saying is we'll be given timings of n meetings in the form of start and end, where start of I is the start time of meeting I and end of I is a finish meeting time of meeting I. Return the maximum number of meetings that can be accommodated in a single meeting room when only one meeting can be held in the meeting room at a particular time. Okay. So what the problem is saying is we'll be given start times, right? Start and end times, right? So at any position, right? I, for example. So this is the start time of one of at position 0, right? And the meeting at position 0 ends at 2, right? It starts at 1 and ends at 2. So another meeting, right, at position 1. Okay, it starts at 3 and ends at 4. Okay, so what we want to do is we want to return, or we want to find out the maximum number of meetings that can be accommodated. There's a single meeting room and all these meetings, right? All these meetings, there are meetings, right? And we want to return the maximum meetings that can be accommodated in a single meeting room. Okay, so that's what we want to find out, right? So for example, now and also the condition is that at any particular given time, right, only one meeting can be held at any particular time. Okay, so for example here, right, for example at this position, so the meeting starts at 1 and ends at 2, right? So for this particular meeting, right, it starts at 3 and ends at 4. Okay, so how can we make sure, first of all, like how can we make sure that uh, a meeting can be accommodated or not? Okay, so for example, right? For example, if we take this case, this meeting starts at 1 and this meeting starts at 2. A meeting starts at 3 and meeting starts at 4. So when there is no overlap, for example, right? So this 3, the starting time is 3 and the ending time of this meeting is 2. Okay, so here there is no overlap. Okay, so this meeting can be started, okay, after this meeting. Okay, so for example, if this is the case, for example, let's say if the start time of a meeting is 1 and end time is 4, right? And start time of another meeting is 2 and end time is 5, right? So for example, can this meeting be started when this meeting is going on? When this particular meeting is going on, can this meeting get started? Okay, no, it cannot be started because the start time of this meeting is is lesser than end time of this meeting. Okay, the start time, because it's conflicting, right? It's conflicting. That is why this meeting cannot be started. Okay, so now how can we make sure that we can conduct maximum number of meetings? So what we can do is, as you know, right? So what we are going to compare, for example, this meeting again, we'll take the same example. If it was starting at 1 and ending at 4, and this another meeting was starting at 2 and ending at 5, right? So what we're going to compare is, we'll compare the start time of one meeting. If it is lesser than end time of the previous meeting, then this meeting cannot be held. Okay, if it is other way around, for example, the start time of the second meeting, if it is not lesser, or if it is greater than the start time of, if it is greater than the end time of the previous meeting, then this meeting can be held. Okay, then this meeting can be held in the meeting room. Okay, so this is the intention behind solving the problem. So what we can do in order to find out the maximum number, in order to accommodate maximum number of meetings in a single room, so what we'll do is we'll sort right, the meetings according to the end time, according to the end times of, okay, according to the end times of the meetings. Why? Because for example, right, again, for example, if we consider this meeting, right, if it is first, right, it starts at 0 and ends at 6, right? And there are meetings which are starting at 1 ending at 2, right? Starting at 1 ending at 2, right? Another meeting is starting at 3 ending at 4, right? So for example, if this is the first meeting and if it is going on, then these meetings cannot be held, right? Because they are conflicting with this meeting, right? So in order to have maximum meetings, what we can do is we'll sort according to the given times, according to the end times. Okay, so that the meeting with lesser end time will finish first. Okay, so here, fortunately, this, for example, here fortunately this is sorted according to the end time, right? This is sorted according to the end time. Okay, so I think this intuition will sort according to the end times and will calculate the maximum number of meetings. Okay, so let's code. I think you'll understand better. Before going to the code, I'll request you to subscribe to my channel. Thank you so much. So let's do one thing. Since we have this start and end, right, separate alias, let's create a class. Okay, class meeting. Let's name it meeting. Okay. And what will be the variables here? Members, int start and int end. Okay. And what we'll do, we'll have a constructor. So first I'll show you Java code followed by C++. Okay. Int start, int end. We have this. Then what we'll do, this dot start equal to start, right? This dot end equal to end. This will do. And what we'll do now? We will store this start and end in the meeting object. So we'll have a list, array list, right? Or let's say, let's take it a array basically of meeting, right? Meeting, okay. Meetings equal to new meeting, right? Of size n, right? Of size n. There are n meetings. So what we'll do now? We'll start with I less than n plus plus I, right? And then what we'll do? Meetings of I equal to new meeting, right? We'll create an object of meeting and start of I, right? And end of I. Start of I and end of I, we took this. So we have meetings array. Now what we'll do? We'll sort this. Arrays dot sort, right? Arrays dot sort meetings. Okay. Meetings A comma B. What we'll do? We'll do A dot get. We have to sort in ascending order of the end time, right? A dot end minus B dot end. So in this way, what will make sure? So all the meetings will be sorted. The object meetings will be, the meetings objects will be sorted according to the end times in ascending order. Okay, according to the end times in ascending order. So it will be like this. So in this example, in this particular example, it is already sorted. Okay, but it will look like this only: 2, 4, 6, 7, 9, 9. Okay, it will look like this only. Okay, so we have sorted according to the end times. Now what we are going to do is we'll take answer variable. First of all, the minimum answer is going to be 1. At least one meeting is going to be held, right? Okay, and another thing is we'll also capture the endpoint of the first meeting, So what it will be? Meetings of 0. Okay, meetings of 0 dot end. Okay, so we have captured this particular, right? So 2 we have captured. We have captured 2 as an endpoint. Okay, now what we're going to do? Simply we'll start with 1. Int I equal to 1, I less than n plus plus I. Okay, and then what we're going to check? If the current, right? If the current meetings of I dot start. Okay, dot start. If it is greater than endpoint, right? If it is greater than, if the next meeting start, if it is greater than the previous meeting's end, right? Then yes, this meeting can be accommodated. For example, right? So here what we are checking here is, for example, if a meeting is starting at 1, ending at 2. Okay, so this is the endpoint, right? This is the endpoint which is holding endpoint, right? And another meeting start is 3, and here it ends at 4. So what we're checking, if this meeting start, if it is greater than the previous meeting's endpoint, right? Then this meeting can be accommodated because there's no overlap or there's no conflict, right? So that's what. So we are going to increment the answer. Also, we'll update our endpoint, right? Update our endpoint with the current meetings of I dot end. We are updating the endpoint, right? So that the next meeting when it starts, right? For example, now, so this is the endpoint now. This is the endpoint. Okay, this is the endpoint. Now we'll check. For example, if this is the endpoint, now we'll check for the next meeting. What is the next meeting here? So the next meeting, it seems it is 0. It is 0 and it is 6, right? The next one. So what we're going to check? We're going to check the start. If it should be greater than the previous meeting's endpoint, but it is not the case, right? Okay, it is not the case. It is overlapping. So the meeting is still going on. So this meeting cannot be conducted. Okay, this meeting cannot be conducted. So we won't do anything over there. We'll simply ignore. So answer, right? Okay, so here, so simply at the end, we're going to return answer. Okay, so this is the solution. This is a solution. I hope you've got the solution. Let's quickly null point exception. We have got y sort 144153. So okay, the silly mistake it is meetings of I it is going to be. Let me compile now. Okay, it's compiled successfully. Let's submit. Yes, the test cases seem to pass. Yes, they have passed. I hope you have got the solution. Please subscribe to my channel, like the video. Okay, let's quickly see the C++ code as well. So that's like here also we are getting the meeting class, right? And then we are having this vector dynamic array. We are pushing the start and end as a meeting object. Then we are sorting. This is a way we will sort A dot end less than B dot end, right? And then what we're going to do, we are capturing the endpoint of the first meeting. The end of the first meeting, we are iterating from the start, the second meeting, right? And we're checking for each current meeting start, it should be greater than the previous meeting's end point. Then only this current meeting can be accommodated, and we'll increment the answer, and we'll capture also the current meeting's end as an endpoint. Okay. So finally we'll return our answer. So this is a solution. I hope you have got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.